teaching lesson. Okay, I'm going to go over topic 7.4, rational numbers on the number line with you. And then tomorrow when you watch the notes, it'll give you even more information and some of the same information. That way you've gotten it at least 2 times, and some of this will start to look familiar. Okay, so right now you should be in your book on topic 7.4, rational numbers on the number line. It's page 192. Okay, now here's a couple things to remember. There are sets of numbers. You guys have used different sets of numbers as you've gone through math. Okay, and as we get older and smarter, we need to deal with harder and more complicated situations. So therefore, we have different numbers for these situations. And you're going to learn about the rational numbers, okay? Now, this means we need different types of numbers that allow us to be more accurate. So as we get into more complicated situations, we need numbers that allow us to deal with those situations, okay? The key when it comes to rational numbers is to make decimals, okay? The key to rational numbers is knowing how to make decimals. And when you see a rational number such as 5/7, you would want to turn it into a decimal. And we know that this is nothing more than the statement 5 divided by 7, which would create a decimal. Okay? So that's the key to dealing with rational numbers, is turning them into decimals or thinking of them as decimals. When you are doing that, you use a calculator. Okay? So this, using a calculator, is important because it allows you to do this, which allows you to deal with that. Okay? So using the calculator is 100% acceptable in this process. Okay? Now this is all being recorded, so if you're taking notes, it'll be posted for you. Okay? Alright, now, here are the sets of numbers. Okay, I'm going to show you the various sets of numbers. And these numbers will start to make sense to you. Okay? The very first set of numbers you learn to deal with are 1, 2, 3, and 4. Those are what we call the natural numbers, or the counting numbers. In other words, when you looked at stuff and started to think mathematically, you began to count, and people began to teach you to count. And these numbers, 1, 2, 3, and 4, worked very, very well for almost all the situations in your life. Okay? And then you began to realize at some point you needed 0, because suddenly you realized, oh, wait a minute. Sometimes I can have 0 cookies. My older brother took my cookies. Now I have 0. Oh, what's that all about? Okay, so the natural numbers are okay, 1, 2, 3, 4. I'm going to count things. And then the whole numbers include 0. And it means like, oh, wait a minute. If we don't have this, this, and this, we have this. And that means something. Okay? Then you go on and this year and years past, you began to realize there was such thing as integers, or you realize you could have the opposite of this and have this. You realized there were negatives, and you realized that, hey, I'd rather be at 0 than negative $3. I'd rather be at 0 than negative 3 homework assignments. Okay, in other words, I don't want to have to make up 3 homework assignments. I'd rather have 0. Actually, I'd rather be here ahead of the game so I can build connects. So you began to think in terms of the integers. Well, now we're going to go into a little bit more complicated layer of numbers. And you've already been working with these numbers, and these are called the rational numbers. Okay, the rational numbers are basically all of those numbers and decimals and fractions, positive or negative. Okay? That's all the rational numbers are. They're just a set of numbers that include fractions and decimals. Bernie?
How come on 0.3, how come there's a line over the 3?
Because that means repeating. That's a good question. We're going to go over that. That line above there means that when they found out, when they said, okay, let's make a fraction, turn this fraction into a decimal, that means the calculator gave them a bunch of threes that went on for infinity. And so what they did was they said, okay, it's a repeating pattern of 3. So we're just going to say that it's 3 repeating. So that's a really good question, which leads us to our next discussion. Okay? On the number line, here's what we have. We have the natural numbers, 1 and 2. These are the those are the natural numbers. Okay? They are the counting numbers. Whole numbers, they include what?
0.
0. Whole numbers include 0. Okay? Now, we've been working with rational numbers, haven't we?
Yes.
Yeah, we've already worked with rational numbers, but we're now applying a name to them, okay, and seeing how they fit in the hierarchy. Integers. So, the integers are going to include the negative numbers, okay? But once we throw in those fractional amounts, we're talking about the set of rational numbers. And so the rational numbers account for any other position on the number line in between solid full units. Okay, that's what the rational numbers are. The in-between amounts. Okay? So, anyways, open up your calculator. Okay? Open up your calculator. Quick run through here. Okay? Now, remember what I said, that sometimes it is easier to work with rational numbers if they are converted to decimal. We're going to use a calculator to write these rational numbers as decimals. Okay? So when we do this, open up the calculator app. Okay? When we do this, this is a negative 1/3. It means 1 divided by 3. Okay? So right now, put in 1 divided by 3 and see what you get as your answer.
3 repeat.
Oh! Ho, 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 ho. There it is.
Put the 1.
Yeah. So instead of writing all those 3's out, we're going to say that that 3 is repeating. Okay? And that's what we mean by the repeating symbol. Okay? So when you're dealing with 1/3 as a rational number, negative or positive, you're never going to get the full value, are you? Because it would be impossible to work with that infinite value. So we're just going to round it. Okay? And in some situations, we have to make a leap of faith. All right, let's try this one. negative 12 fifths. Let's put that into the calculator and do 12 divided by 5. Elijah?
2.4.
Yep, 2.4. So that would be converted over to a negative 2 4/10. Okay? Now you can find those on a number line easily, couldn't you? Now you can kind of compare these and you can say, oh yeah, this one is definitely less than that one, isn't it? Because you'd have to go way farther left in order to get this one. You would cross that one, you would pass that one going left in order to reach that one. Alright? How about the 3/8? 3/8, what would it be if you converted it? 3 divided by 8. What do we have? Peyton?
0.375.
Perfect. 0.375. This is a terminating decimal. This is a terminating decimal, which means that it ends right there. Okay? So, whenever you are working with rational numbers, it is often easier to convert them to decimals, especially if you're going to compare them on a number line. It's definitely easier to work with decimals because now you can say, okay, this is positive, so if we have 0 and here's our number line, we know that this is going to be somewhere on this side. This is going to be on the left side because it's negative, and it's going to be way down there, and this is going to be somewhere close in between -1 and 0. That's why we convert them into decimals. Alright, so the book then goes on and it introduces them and it says, how can you compare rational numbers on a number line? And any number that can be shown as the quotient of two integers is called a rational number. So the quotient of two integers, meaning the division we just saw, is a rational number. So for any integers a and b, provided b does not equal 0, notice the fraction, a and b equals a divided by b. That means you can create a rational number. Okay? Just a lot of wordy math stuff. So, rational numbers can be written in different ways. They can be written as fractions, or they can be written as decimals. And so if we were going to compare these and decide which was greater and which was less, well, they're both negative, so we know that they're both on the left side of 0. But the interesting thing here is we can kind of right off the bat say, okay, I see that I have a full unit, so I know that that one is going to pass -1. Is this one going to pass -1 too? Is it also going to be past
No.
the -1 also?
No.
Now be careful, you have 4 up here. Take your calculator out. Let's convert it into decimals. Let's take 4 divided by 3. Okay? Oh yeah, there we go. It's 1, 3 repeating. So this -4/3 is actually -1, 3 repeating. So now we can say, okay, if I compare these two and I line them up and I take -1, 5 and -1, 3, I can begin comparing them and saying, well, they both have 1 in that place. Uh-oh, this one has a 5. So it's actually what on the number line? Aiden?
Lesser.
It is lesser. Yes. And that's a tough word to comprehend, but yes, it's further away. It has a lower value. In other words, we would say to ourselves, okay, 1 and 3, a -1 and 3/10 is right there, and a -1 and 5/10 is right there. So you'd have to go further left to get to that one. Okay? And so that's how you can use decimals to compare them. Alright? So the book then goes on and it says exactly that. Think of a -4/3 as a decimal. So in this situation, they have the -4/3. They converted it to 1 and 1/3, and then they took that 1 and 1/3 and made it a decimal. Okay? On a number line, a -1 and 3/10 is to the right of a -1.5. So therefore, this one is greater than this one. Okay? You can also think of 4 and 4/3, -4/3, and -1.5 as mixed numbers. And you could compare them that way. And then they show you how you turn them into mixed numbers and view on the number line as mixed numbers. It's a little bit easier if you just convert them to decimals. Okay? Alright. Any questions related to that information? No? The book then goes on to give you some examples of how you can find and compare rational numbers on a vertical number line. Okay? And it talks about pilots and then hot air balloons and how they use different air currents at different elevations to steer the balloons. So if a pilot is at a certain elevation and they want to go west or east, whatever direction this might be, they have to increase their balloon and then they will catch that current. If they keep heating up the air and they go a little higher, they will then go in that direction. Okay, so they make the balloon climb or descend to an elevation with an air current blowing in the direction they want to go. The diagram shows the direction of wind at different elevations relative to the balloon. How far will the balloon have to travel to reach the nearest air current that is moving left? Okay, so now what we can do is we can begin to compare distances and decide, do I elevate my balloon or do I decrease my balloon? Because there's two air currents moving to the left, this one and this one. And which one are they closest to? Are they closest to this air current right here, the negative 95 feet? Should they go down negative 95 feet or should they go up 250 feet? Well, the obvious answer is they should do what? They should go down, right? Because this is definitely greater than that. So if they want to get moving left, they have to decrease. Okay? They have to use the negative. Okay? Alright. So, there you go. That is all the marvelous stuff related to integers that you need to know. Tomorrow you'll review it. You may close your notebooks up, take a quick restroom break. We are ahead of schedule.